Hey guys, welcome to Safi Mixed. In this video, I want to discuss a phenomena that you may have observed. If you haven't observed, I would suggest you to do this experiment. If you inflate a balloon and then close its mouth tightly so that no gas particles could either leave or enter the balloon, and you leave the balloon at a table for a little longer, such so that the balloon is both in thermal and mechanical equilibrium with the atmosphere. It will be in mechanical equilibrium if the balloon is not expanding or contracting, and similarly, that reflects that it is in thermal equilibrium as well, because if the temperature is changing, the volume would keep on changing. Now, if you put the balloon inside a freezer, the temperature of freezer is usually below than 0 degrees centigrade. That's why water freezes inside it. And you leave the balloon for a while inside the freezer. Uh, you will see after a long time, after a certain time, if you open the freezer and look at the balloon, it would have been collapsed. The size of the balloon would have been reduced. uh, I want to discuss this phenomena. Why is this happening? When the balloon is outside the freezer and it is in thermal equilibrium with the atmosphere, that means the kinetic energy of the molecules of the gas inside the balloon is sufficient so that it is bombarding, it is colliding against the wall of the balloon and exerting a pressure equal to the atmospheric pressure, keeping the size constant. Now, when you put this inside the freezer, the uh, the walls of the balloon are dithermal, means the walls, the wall allows heat to flow inside or outside depending on the temperature. Now, the when you place it inside the freezer, the temperature of the freezer is well below than the temperature of gas inside the balloon. So, being dithermal, the wall allows heat from the balloon to flow out of it, thereby reducing its thermal kinetic energy. And reducing thermal kinetic energy means the force the molecule exerts on the wall and collision is now reduced. And that reduced force, that reduced pressure allow the balloon walls to collapse. So it is in fact the reduction of thermal energy or the flow of thermal energy from the gas molecule to the freezer that allows the balloon walls to collapse. Thanks for watching.